I don't know what the expectation is. It's like more.
Hey, good evening, everyone, and thank you for coming to tonight's DC iOS meetup. Sorry for the delay. I know, once again, I forgot to send out the Zoom link, my bad. So for context, to those who don't know, unfortunately, Meetup is actually blocked by our corporate proxy, so I have to do everything off my personal computer or my phone, so it means I tend to forget once I actually create the Zoom link to actually share it. So my apologies. So thank you once again. I'm Scott Luxembourg. I'm one of your co-organizers. Obviously, Mac is my other co-organizer. You'll hear from him very shortly. So thank you for coming to tonight's meetup. Obviously, I think this will be a very interesting one, especially, I know I've been paying a lot of attention to performance lately. So hearing how to optimize performance for SwiftUI should be very interesting. As usual, I think I've muted everybody, so I will either unmute or allow people to ask questions on the chat, and we'll do a little more of unmuting later. So we'll go through the talk, have a little time for networking, and I'll have some announcements at the end. But without further ado, it is time to hand it over.
Okay. Sorry, just give me 1 second to set up my display. All right. You can hear me okay in the room as well? Okay, hello. Thanks for having me. My name. Oh, no. It's not cut off on my display.
Oh, there we go.
Okay. We still good? Or is it cut off? Good. Alrighty. My name is Mac. I'm a technical architect at the Washington Post, and tonight I'm going to be talking a bit about what I've learned about SwiftUI, its performance, and the changing attitude I've had about it as we've increased our adoption of it for new features in the app, and just the general things that I've been learning about SwiftUI and performance aspects of it. Just a bit about me and why I chose this topic and why I'm talking about it tonight. Performance is an aspect of application development that I really enjoy. And one of the things that I really like about it is that I can make changes and then measure the impact of those changes, sort of like to quantify the impact of the code that I write. And performance is an aspect where I can do that really easily in an isolated way. And just a bit of history, over the past 1.5 to 2 years, I've been assigned sort of the point person of performance in our application and making sure that that's a consideration that is taken into new feature development and existing feature maintenance. And I've gotten my team also to adopt sort of the practices of continuously improving performance, reporting and monitoring performance of the application, and adding new aspects of performance that we are evaluating and reporting on to ourselves. So setting the stage, this year we adopted SwiftUI for, I guess, our first larger feature. We had previously had widgets. So we did have some experience writing and shipping SwiftUI code, but not in our primary application target. And as I mentioned, having been so interested in performance, I had this bias and was sort of skeptical of SwiftUI in a performance sense. And so I was the first one to raise my hand and say, I don't know that we can do this because I don't think the performance of it is good enough for the application. And that's sort of where I started, and I have definitely shifted my perspective and have embraced SwiftUI. And I think that it's a misconception and maybe a misunderstanding of what SwiftUI is and what it does for us as a UI framework. So if we can talk a little bit about some of those things. So I'm saying performance, and I'd like to go into what I mean for that, especially in the context of this talk. We're going to talk about the render loop, then SwiftUI view identity and lifetime concepts. I'll show the various instruments and how I use them with SwiftUI, and then we can do questions that you have. Okay, so what do I mean when I say performance? Because it can mean a lot of things. For the purposes of this talk, we're primarily focusing on rendering performance. And then, as I've called out here on the Xcode metrics organizer, these are things like hitches and hangs that we're addressing. And these are the two primary aspects that I'll be talking about, though I don't discount other performance metrics. So this is sort of my thesis for this presentation. I hope it's kind of a good way to describe what I'm trying to convey, because I find that at the end of this talk, I still don't feel like there's a so what. But the main takeaway the main thing that I've taken away in watching all of the talks that Apple puts out about SwiftUI and performance is that in order to understand performance or to think about performance or optimizing its performance, we need to understand how it works. And I think this is a big reason why there's a lot of the same word in those talks, that it's about demystifying it, because it's hard to focus on how poorly it's performing if you don't understand what it's doing. Separately, I think that understanding how it works makes you better at writing and reading SwiftUI code. Okay, getting into SwiftUI's render loop. Okay, let's take a moment to review this code. And I'm posing a question here. So my question is, here's our model. It's publishing changes to its status property. And I have a SwiftUI view, my content view, with text of that observable status value. Does anyone want to take a guess? Can we say reliably that we will never see initial, or maybe sometimes we'd see the value initial rendered? So the short answer is we will never see initial, and the view is only going to be rendered once, at least this view, the way it's described here. And in order to unpack that, we have to understand what's going on with the render loop and how SwiftUI builds on top of the render loop. If you've not heard of the run loop before, also CF run loop, as I call it here, the core foundation run loop is a technology that's been around for a long time, and there are many popular technologies that you probably already know if you don't know the run loop that build on top of this. So main actor, and then in the more modern Swift concurrency, the main queue, the main dispatch queue, and then in Swift concurrency, the main actor, SwiftUI and UIKit both build on top of the run loop. And this, I think, is important to understand because it helps frame the boundary of SwiftUI in terms of its performance as a UI framework. Okay, so this is a little diagram that I've made of a high-level overview of what the run loop is. It's a continuous process here, and these are a few phases. A run loop waits for input sources that have unique types, which are then processed by the run loop. And separately, these are called activities. We can register to observe when the run loop enters phases of the run loop. And this is how both UIKit and SwiftUI work, or they build on top of this. When your app is launched, it starts a run loop on the main thread with an input source to deliver touch events. So we're all familiar with touch handling. Things like gesture recognizers and observing touches work based on this. Here I am showing the backtrace. It's a little fuzzy on this display here, but hopefully you can read. The mock message is a system call that CF run loop uses to wait for events. So when you pause your debugger there in Xcode, you may have seen this. That's what's happening. Down here at frame. Okay, going back to the run loop observers. So these are various types of input sources, and touch is one that we're focused on. But one thing you can do with the run loop is register an observer when it enters a certain phase of the run loop. For example, documentation page, you can see that these are the different activities and sort of what that code might look like if you're setting up an observer for one of the run loop activities. And one thing that happens is the run loop makes all its calls through these marker functions so that they're easy to see in stack traces. So you may have seen this when you're paused in your debugger or you're investigating a crash log or otherwise looking at a backtrace. You may have seen these run loop marker functions. And what they're telling you is this is where the run loop was at this point in the stack trace. The functions don't do anything. They're just there as markers. We could use this if we want to explore what's going on with SwiftUI to understand how SwiftUI and UIKit use input sources and observers in order to work as a UI framework. So here I'm paused. And this will be important maybe in a moment. But you can see hopefully that I'm paused in some arbitrary view body. Oh, sorry. In this case, I'm paused in the button callback. This is the tap handler for my toggle button in this application. And you can see that the run loop is calling out to a source 0 perform function. This is because the touch input is of that type 0 input to the run loop. And is treated, there's a certain handling of different input types by the run loop. So then how does this run loop relate to the render loop? So the render loop is the process that all work for each frame that is displayed by your application. This happens at the refresh rate, which you may have heard of before. And for most iPhones, that's 16.67 milliseconds per frame, though in some cases, the refresh rate can be 8.3 milliseconds at a rate of 120 hertz. Okay, so this is from Apple's exploring the Hitch instrument Tech Talk, and it outlines a basic overview of the render loop. There are 5 phases called out here, and you can see how each part of this render loop is broken up. So this represents one frame that is displayed, and the rate of that refresh is driven by hardware. In terms of the run loop, touches can be delivered faster than the refresh, but in UIKit and SwiftUI, that's not the case. Touches are coalesced. So if there are multiple touches during a single frame, we will receive the touches, the intermediate touches on the next frame. It's sort of like UI touch. They're coalesced. Oops. Primarily when we're talking about input sources, touch handling, keyboard handling, things like that, we're talking about the event phase of the render loop. UIKit and SwiftUI work the same in this regard. In this phase, we're processing events. So a user might tap a button, we might receive a network callback, anything that might result in a change to our desired change to our application's UI. So we process the events and we modify view state at this point of the render loop. Let's see. So when I said that we're updating, we're processing events and updating our application's UI. Nothing is being rendered at this point. We are updating application state to mark views as dirty and needing to be rendered. SwiftUI and UIKit both do this. In UIKit, you may see some code like this, where we're setting the background color. And internally, what that does is sets that this view needs display or needing to be redrawn. And in SwiftUI, we are changing the state of our views. So in this case, I'm setting is on, which will ultimately change the background color and the height of my view. Both of these start an implicit transaction, which I'll get into in a minute. And if you think about the run loop, during one frame in the run loop, we are modifying view state. And one strategy that both UIKit and SwiftUI apply is that we do not commit any of those changes immediately. They're committed on the next run loop. So in this case, if I validated my UIKit view or SwiftUI view multiple times during one frame, we're only going to be rendering that change once. And this makes sense because there's no need to display a view that's in between states. We will sort of wait for the full set of changes to be rendered. When we look at the SwiftUI instrument, you'll see that there are CA transactions called out explicitly. And that's because core animation in both UIKit and SwiftUI is talking to the render server and is starting a CA transaction whenever we are changing our view state in a way that's going to need layout or redrawing of our views. And this is done in both UIKit and SwiftUI using a run loop observer. It's in both, it's waiting for a callback that the run loop has entered the before waiting phase of the run loop, which is effectively the end of the loop before we begin waiting for our input sources. So here's sort of a fuller picture of the run loop and SwiftUI. Like in UIKit, if we invalidate a view multiple times during one frame, it doesn't really matter because the body evaluation is scheduled for a later time. It's scheduled for the before waiting phase. And this is also when the SwiftUI framework will reevaluate the view bodies of your views that have changed automatically. This is the power and the magic of SwiftUI that does not exist in UIKit. So if you imagine our SwiftUI view, and we've changed the isOn state property, we now evaluate the body of the changed view when the run loop enters the before waiting activity and produces a new view from the changed view and determines, right, so SwiftUI sees that our SwiftUI view has changed. Its isOn is now true. When we enter the before waiting phase of the run loop, our new view body is ready to be displayed. And before that, what SwiftUI does is calls onChange, onPreferenceChange, and onAppear. And this is a little different than UIKit, but the reason we do this is to give those views a chance to invalidate their view again. So if we subscribed change handler to is on, that then invalidated the view again. Let's see. You may see something like this. And SwiftUI is not using a run loop observer for this change. What happens in this case is SwiftUI temporarily disables the update handling for views and then logs this message that you are attempting to invalidate your view multiple times per frame. So that's primarily the event handling phase. We've received input from things like touches and networking. We've changed our view state, and now we're moving to the commit phase. So this is the end of the run loop, and we have our new view state, and this is described as where we do layout and drawing. So conceptually, you could think of this as these are UI and SwiftUI versions that I could come up with to illustrate this. For a view, that's layout subviews and draw rect, and it goes parent to child. And for draw rect, views will get a texture backed context that they can draw into that is then passed to the render server. Okay, so we're done with our commit, and we've packaged up all of our views that have been laid out and drawn, and now we're in the render server. This is where the layer tree goes to the render server, where it is serialized, not serialized, turned into a linear pipeline that the GPU can execute. One note about this is this can be a different source of hitches, the render prepare and render execute phase. And I'm not touching too much on this, but there are things that can cause hitches on the render server as opposed to in the commit phase. And solutions for those can be different. Okay, so we have the rendered output from the GPU where we pass this linear pipeline from back to front of our layer tree. And each layer is then composited into a final texture, or just think of it like an image. And in some cases, that can take longer and be a source of hitches. And I'd recommend, if you're unfamiliar with hitches, that you take a look at that tech talk from Apple that explains the deadline here that I'm trying to call out. But every frame, every frame in the run loop has a deadline. That deadline is when the hardware emits a vsync event, and the frame needs to complete in time. Otherwise, it misses the deadline. You see a missed frame. That's what we think of when we think about scroll hitches and drop frames, things like that. It is the result of a delayed frame, or a frame that took too long to complete. So again, commit hitches, we took too long to process the events, like handle touches or keyword input, or we took too long to commit draw, layout, or subviews of those things. And then rendering hitches can be things like masking, shadows. There are lots of sources of render hitches, but kind of get into them different time. Okay, so we've looked at the run loop. We've looked at SwiftUI's render loop that's built on top of the run loop and how it's very similar to UIKit. And this is where things really depart, because SwiftUI deals with the concept of identity very differently, as well as the lifetime of the view. These are also listed as precursors or concepts that Apple would like you to understand before you start any of their demystifying talks, but they don't really have a talk that dives into these topics specifically. It's sort of covered elsewhere when they're talking about the framework itself. All the views in SwiftUI have an identity compared to UIKit. Our views don't have a pointer to use as an identity because they are value types. And UI frameworks like React all sort of solve this in different ways, but SwiftUI, I think, made a good choice here because the default is something you don't have to think about, and it's fairly performant because it's not using something like a hash, or it doesn't require equality in order to identify a view. So what you get most of the time, as we saw in the example code before, is the implicit identity that SwiftUI infers from your view, although there are other scenarios where you can provide an explicit identity, and that can, there are reasons why you might want to do that. So this is an example of an implicit identity with a state, and the implicit identity that you usually get from SwiftUI is the static type. So you could think of this as like a body that has the type, the identifier of its type of self, which you don't ever really see when you're writing the source code because SwiftUI erases that for you. So you don't really look at these types very often. And then a view can have an explicit identity like this, where I'm explicitly assigning the ID of the URL. You may have seen this in some of the view builders, like for each, where we are providing this ID key path for the views as their identity. So we have identity, our views have an identity, but how does that relate to their lifetime? When I think about a UI view, I know when it's initialized, and I know when it's deallocated, and those are clear to me. But it's not very clear to me in SwiftUI. So Apple tells us the lifetime of a view is the duration that it has the same identity. And if we think about what we talked about before with a little bit of the diffing, you can think of this like when the ID of a view changes, it is being removed from its super view or removed from your view hierarchy, and then potentially added back again with the changed view state. Okay. Eric sent me this, and I watched this talk from Chris Idoff, and I'm have borrowed his example here because I think it illustrates this concept really well, the concept of identity. So I will pause to let you look at this code for a moment if you haven't seen it, and present a question, a scenario. So I have this image view. It's displaying either an image or a progress view. And if you are unfamiliar with task is started when the view appears, when it's going to be visible, and is automatically canceled when the view identity changes if the task is pending. And it's run once. Right. Okay, so question. Let's say that the URL of this image view changes from this value placeholder.png to logo.png. Do you think that this task runs twice? Does it run again when my URL changes?
No.
Yeah, I'm leading here a little bit. Yeah, it does not run again. And the reason for this is because the ID hasn't changed. The identity of the view hasn't changed. If you remember what we said about the implicit identity here, SwiftUI understands this image view to have an ID of its static type, which you can see here has not changed. The only thing that has changed is my dependency URL. So body will be reevaluated. SwiftUI can see that this image view has changed, something about it has changed. What it can't see is that it needs to be redrawn, or I guess that it's fundamentally changed in this way that we would maybe expect. So how do we fix that? Well, we can do what I said. You can assign an explicit identity like this. This is the ID modifier. We assign the URL. And when this happens, yep, SwiftUI will see, okay, this is a totally different image view. So it will remove the image view, or we can think of it as being removed from the view graph, and then a fresh image view is added again. Our task will run again, and we'll display the expected image. But if we think about the contents of this view and the work required to redraw the image view, maybe we'd want to do a little bit better than that. So we can assign the ID here for this task. And in this case, this is the part that will change, that will run again when our image view changes our task. We'll start a new task, and the old one will have been canceled. So we just saw an example of dependencies and a little bit about how they work. But I think one takeaway or one thing that I see people sometimes conflate is that the dependencies are the identity of the view, and that is not the case. Okay, and these are examples both of dependencies. So I have state, I have bar condition. SwiftUI doesn't, for the purposes of understanding that a view has changed, necessarily consider these any different. If you change either these values, the view body will be reevaluated. The state property decorator here is for dealing with storage as it relates to the lifetime. Yep, SwiftUI tracks dependencies and calls for new view bodies when any of those dependencies change. Okay, back to my example code. So I'll show you this is a simple model. It's observable. And the thing that I'm going to be observing is this content string property. Here's my content view. It has this observed record, and it's specifically observing the record's content. Here in my text field, where I've set up a button that does nothing. But what I've added here that you haven't seen before is a rainbow debug view modifier. And maybe some of you have seen this or used it in your own debugging, just in terms of understanding how SwiftUI processes your view updates. This is that code. It's really simple. It's not doing much, just picking a color from this rainbow debug colors array at random and assigning it to the view's background. Okay, so here's my playground or my preview, and I'm typing in. And what you can see is that the background color of my content view is changing every time the view state changes, which at this point seems somewhat expected. This is how SwiftUI is supposed to work. But if we think back about maybe optimizing it a little bit, we can take a different approach. And this is sort of the approach that Apple suggests, that we isolate this dependency down to the specific view. So the idea is that you extract some of those into smaller subviews because there isn't necessarily an overhead like we have in UIKit, where we have a view that is layer backed in order to extract to a subview. SwiftUI will flatten the view hierarchy for us to some extent. So what I've done here is modified it, extracted the content field, this text field, into a new view that observes the same state, the content of that observable model. And we can visually see the difference when I change the state. None of the other parts of my application's view hierarchy are being redrawn, only the text field that I'm changing the state of. Moving into instruments. So Apple introduced the SwiftUI template, instruments template several years ago, and doesn't offer much documentation about it or how you should really leverage it. There are some guesses you can make, but if you've not done it before, you'll run your app for profiling and choose the SwiftUI instrument from this profiling menu. And then, of course, you want to make sure that you're profiling on a physical device and not a simulator. since otherwise you'd be sort of measuring what's going on your machine more than a real-world performance of the application on the phone. And once you do, you'll click the record to capture some data. So if you're profiling a particular performance problem, you will exercise the code a few times and find a recording that best captures performance problem. These are the lanes of the instrument, and call them out here, and we'll talk through a bit about each one and what they mean. All right, I've lost my notes. So here I've pinned the view body track of my run. And you can see here that there are summaries of the timing of all of the view bodies that were evaluated. So we saw before how when I changed my view state, SwiftUI automatically saw that and created a updated copy of my view body to determine if it needed to be redrawn. In order to do that, it needs to evaluate the view body. And I think this is where we've seen performance issues, and it's a very common source of performance issues, that evaluation of view body needs to be really cheap because it happens a lot. And I have some tips at the end for common sources that you may think are unexpected of slow view bodies that you sort of look at. Instruments is hopefully also giving you a filter here where you can look at slow view bodies and slow frames during the render loop. And this is the Fruta app from Apple Sample Code Archive, and you can see that it's nicely showing me the different types of views that I've defined, as well as ones that are being used internally by SwiftUI and those types there. Okay, this is an example of what a slow view body looks like. Moving on to the view properties, these are all of the updates that have been made to your view state for the reason that SwiftUI reevaluated the body. And if you're familiar with the print changes helper function, this is, I think, a much nicer way to look at that data. So if you've been debugging and throwing in the print changes function, I recommend using this instead because it gives you like a nice organized view of all of those changes that resulted in that resulted in calls for a new view body. And this can be especially helpful if you're seeing your view body evaluated more often than you expect. We're scrolling a list and we're seeing more updates than we expect. We can look at exactly where those updates are coming from to determine if we are expecting them or not. And again, just a different view. This is the summary. Okay, so this is where I think maybe there's a disconnect between maybe folks who are focused on SwiftUI as the UI framework, maybe coming from UIKit, or maybe not, and may not understand exactly how the commit instrument in this template is meant to be interpreted. But as we saw in the explanation and overview of the render loop, our commits are representing those frames that are displayed, and we can see which ones are particularly slow. In this case, I also recommend, but this is my approach, but I recommend separating by thread and then inverting the call tree when you examine this. Find that it's an easier way to look at sort of the thing that I care about, which is what is the most expensive thing that's happening here in this commit. And this is like a pretty common thing that's going on, the JPEG decompression that's happening here on the main thread in the Fruta iOS app. And I won't really talk about solving that in this talk, but we could go forward in a question. Okay, so yeah, again, we saw in the render loop overview that this is the commit phase, and this is where layout and drawing are happening. And it's a bit more difficult to see the connection between your SwiftUI view changing its layout and UI kit, since the layout happens sort of separately. But it should all be captured here within this single transaction. So a view is marked as being dirty and needing, in some cases, needing to be resized or relaid out. And SwiftUI will do that within that frame. SwiftUI generates this size delegate that you can see for certain things like text. So for us, a common thing that I see that's fairly expensive in terms of sizing is string sizing. And the time profiler. So this is where you might see exactly what is happening in your application and in SwiftUI. And if you see, this is interesting to me because to me, it feels a lot like the new Objective-C message send maybe, or something where it's a very expensive thing that's happening in my opinion, like if you're profiling our SwiftUI code, that Swift here is pulling out the type information from the type at runtime and is using that to form the identifier. So an identifier can be expensive if that type information is not cached. I believe it's been optimized over the years, but getting the type of a Swift object can be particularly expensive, especially if it's happening at a time when there's a lot of other work that's already happening to draw the frame. I will say, though, that I've had a terrible time symbolicating SwiftUI on my machine, and it works about 1 in 10 times. And I really wish someone would tell me what the magic trick is to make that work, but I have a feedback, and if anyone knows, let me know. If SwiftUI symbols don't work on your machine, you're not alone. You can click symbolicate this. It will point you to the exact directory where it seemingly does exist. You see, here are the dsymbols for SwiftUI, and it says great, and then it continues to show you the unsymbolicated calls. But I don't think it matters that much. I think it's just interesting to see what SwiftUI is doing, maybe in case it's a hint into maybe where we could be optimizing more. And new this year to the template for SwiftUI is the hangs instrument. And hangs are, or I guess if we go back and think about the run loop and the event phase of the render loop, hangs are when our application is essentially not responsive. And so if we think about expensive view bodies potentially, or how these relate to hangs, if our application is taking too much time processing the view body or processing events generally, this can result in an unresponsive application. You can see this here. I think this is me adding a sleep to my tap handler in order to illustrate what that looks like here. Or you see there's like a 1 second hang because it had a 1 second sleep. And it will tell you that there are different severities of hangs. So you might have relatively minor ones that are not concerning versus very severe ones. And back to the, I guess, under the hood view, that is a terrible view of that. So I zoomed in to try to show it, and I still don't know if it's going to work. But if you're ever curious, I think if you go into Xcode's view debugger, I haven't tried this with Reveal, so I don't know what it's showing you here, but in Xcode, if you're looking at the view hierarchy of a SwiftUI application, it shows you a lot of these non-layer backed views, which is really helpful if you're developing and thinking in SwiftUI. So we have like our stacks and our all of the different subviews. But if we ever are curious at what the layer tree looks like, we can print out the recursive view description, which is here what I'm showing you, And you can see the internal UI views and these CA layers that back them before the application's hierarchy. And you can see here that there's quite a few SwiftUI views in this tree, but not as many views and layers when I examine the window. These are some tips that Apple gives, and I think they're helpful as just generals of thumb, but I do think that framing them with knowledge about how SwiftUI works makes it maybe more, or gives us a better way to understand why maybe we would want to adopt some of these tips. They recommend avoiding any view because it erases the type, and as we understood before, the type is the sort of cue to SwiftUI that view needs to be redrawn potentially for an implicitly assigned identity. And so the best that SwiftUI can do when your view is drawn with any view is say, I don't know what changed, so I'm going to have to redraw it. So if you're using any view and you're seeing excessive drawing or excessive commits, anything like that, definitely want to look at avoiding that since it's relatively easy to fix. I think the main reason that we had it in our code base before is that we had, I guess, explicit typing and non-erased type signatures for functions or as arguments, and used any view to erase the argument of this view that we're passing. And you can use view builder instead, which will erase that, or it will allow the compiler to see the type and be satisfied, but for your signature to be more flexible. And SwiftUI provides a lot of ways that you can implement lazy loading. These are lazy versions of those stacks, the vertical and horizontal stacks in the grid. And this is something that we saw is that, or just something we weren't thinking about immediately because we're so used to thinking in terms of sale reuse and in a scrolling list like collection view or table view, that lazy does not purge the view, I suppose, when it's no longer visible, which of course makes sense when I say it, but maybe isn't obvious when you first think about it. And so for this reason, I think it's important to be aware of any expensive state. So if you have a UI image or a Swift image for that matter, the image may be decompressed and taking up a lot of memory. And so if you have a scrolling list that's evaluated using a lazy V stack, if you imagine scrolling the whole list, what you'll see is memory growth that looks like this, where there's possible issues. So something to be aware of. And when we're thinking about the view body, these are some common sources that Apple calls out that you might not be aware of. So we had something like this, and I think it's maybe because we're still thinking in terms of UIKit and trying to sort of like reuse the view instead of thinking that, okay, our view should be really cheap and its body should be equally cheap. So in this case, we have placeholder, which is this closure, and this can actually cause separate bugs because of identity. But for this purpose, the thing to know is that this will result in a heap allocation. And if you imagine a scrolling list, let's say that the view state one node up is changing and we're reevaluating all of the loading image views in our list, SwiftUI will have to recreate that and result in many heap allocations for those views. So this is something to avoid. And you can easily replace this by evaluating the closure and just storing the results of it on the view itself. String interpolation. This is something that I've seen in our code that in the view body, we're doing lots of string interpolation, but this can be pretty expensive, especially for a view whose body is evaluated frequently. And ideally, you can move that to your model or to somewhere where it won't be evaluated as a result of the view body. Bundle lookup, images. So if you think about images from an asset catalog or images stored in a different bundle and you're looking up the bundle in the view body in order to display it, this can commonly be a source of slowness. There's some caching of that lookup, but You may be seeing that. And expensive identification. So if you're forming your own, or as we saw in the time profiler, sometimes deeply nested types that have very complicated identities to infer implicitly, your view can be expensive for that reason, since it's essentially a part of the view body. This is one that we've applied recently. It's a view modifier that ships with SwiftUI, and it will, see, I have some better notes about this. Yep. Okay, so the contents of your view, when modified by a drawing group, are composited into a single bitmap and then displayed in place of the view. So it essentially turns your view into an image of that view instead of sort of like a live view or stateful view. And this incurs, or sort of, it can incur additional memory because you do need to create the allocation for that in-memory image. And that's exactly, I think, what maybe one of these screenshots was showing. So this growth actually happened because of a drawing group on a lazy VStack. Growth, problematic growth. Okay, so that's mostly what I have to share. And hopefully what I've connected for you is that SwiftUI and UIKit are fairly similar in terms of their performance boundaries. And I think it's a pretty unfair assessment to say that SwiftUI is simply non-performant. It's just a misunderstanding of what it's doing or what it should be doing for you. And in fact, if anything, SwiftUI has the potential to be more performant than UIKit because it can helpfully eliminate unnecessary redraws. But some of that may be up to you to determine. And so what's next for me and where I want to take some of this to my team, this is mostly helping me in code review to better understand view and state and identity and to spot potential issues. And one area that we haven't gone into too much depth on in this talk and an area that I've put on my sort of knowledge debt list is to dig deeper into the layout process and potential for optimizing there, because we do a lot of optimizations, like on our main feed, for example, for layout, and we're not doing that yet with SwiftUI. We've only written, I think, maybe one layout, but that's an area that I'm looking to next. I will link all the resources here. These are the Apple Talks and then a couple of blog posts that I referenced. And I'd like to move now into your questions, if you have any.
Thank you. I know we did have one question that came in earlier in the presentation. Ed asked, if a display drops with a lower refresh rate, about 10 hertz, does the render loop slow down?
So if we have a dynamic refresh rate and it's slowing to say 10 hertz, does the render loop slow down? The render loop absolutely slows down. What does not necessarily slow down is the run loop. You could think of, like, if you think about CA display link and touch input handling. So they happen at about the same rate, but not necessarily. And what CA display link gives us is the ability to synchronize event handling with the refresh rate. So they're separate, I guess, in refresh rate, and I guess the rate of rendering is somewhat independent of the run loop and event handling.
All right, thank you. And then Jake had asked if there are any resources to explore this more thoroughly. I know you did share the resources slide. Are there any other resources that you didn't list there that might be helpful?
I would start with if the concept of rendering performance is new to you, I would absolutely start with the Explore UI animation hitches in the render loop, which does a pretty nice overview of it, especially if it's a new concept to you. And from there, look at these demystified because they will make a lot more sense with that foundation. As far as resources that are not listed here, I have a few, and I could put those up somewhere, or maybe when we upload to YouTube, I can add a slide for that. I found some really great blog posts, and sometimes they're written from the perspective of understanding like the SwiftUI view lifecycle as opposed to the UI view lifecycle. I think a lot of times people come from UIKit into SwiftUI and don't quite understand why we have so many callbacks for a UI views lifecycle, and we really only have on here for SwiftUI, for SwiftUI view. So I've seen a few of those, and those have been helpful for me forming some understanding. I'll find a way to maybe post those links.
Thank you. And I know I can actually plug the Chris Eidhoff talk. Our kind of sister organization, iOS Soho, actually had Eidhoff come and gave that presentation. I don't think that video has made its way up on YouTube yet, but I think that should be coming soon. All right, for any other questions, people here in the room, raise your hand and I'll bring the mic to you. People have resumed, just drop questions in the chat and I will come back to you. Any other questions? Going once? Oh. Yeah, of course, I know you're going to have a question about performance.
You had mentioned there was a bunch of different things that you'd often do to try to optimize for some performance issues that you guys ran into. Can you kind of speak to some of the common things you did? Was it just simplifying the size of the model that was being observed? That was one example you showed, but any other obvious ones that you kind of ran into frequently?
So let me go back. So this one's interesting, and what we were trying to do is mimic a different UIKit setup we had for a scroll view content offset observer. Like we have this system that powers the animation of a navigation bar in concert with your scrolling, just like a collapsing navigation bar. So we had this new SwiftUI feature, and the way we did that is using this preferences API, which is a way for a child view. Sorry, to the non-presenter display. My bad. How terrible my notes to myself. Okay, so we use this preferences API to do that, and we did see this particular issue. And one thing that's we haven't adopted yet that I anticipate we will to improve on this. We fixed that problem, but sorry, there we go. So you may see this, and what SwiftUI is trying to do is to break out of your what would be sort of infinite loop. And we had this going on with the preferences change callback, where we were invalidating a view that's in process of being updated. And that's because we sort of like needed the rendered, I guess, content offset, if I think of it that way, in order to inform the state of this. And in iOS 17, there is a scroll effects. Someone can correct me what it's called. A scroll effects API that replaces this kind of entirely to solve for what we were trying to do. And ultimately, what we did is just move that state entirely out of that view tree into sort of like a parent that would prevent dirtying of the view. Separately, I mentioned the drawing group. So one thing that I'll say is with this information, I'm now thinking in terms of how performant can it be if it's written in UIKit? And maybe the way I unfairly entered the conversation about SwiftUI and performance is that I pulled some sample code down from Apple. Like the Fruit app is certainly a non-performant app. It has lots of scroll hitches. And in any case, like you sort of get this, I don't think that that's necessarily its focus as a UI framework right now, but I do think that it will improve as time goes on. But anyway, so as I jump in to SwiftUI and write something out and sort of see how performant it is, or measure it, or just and sort of using it, and what I can see is that it's not nearly as performant as our UIKit code. And I don't think that that's a totally fair fair judgment of SwiftUI, because our UIKit code is subject to many years of iterative improvements, and our SwiftUI code is just not there yet. It's brand new, and we haven't spent much time trying to optimize it. So at least when we talk about like a non-performant SwiftUI feature, we also, at least most recently, have made sure to kind of check on how performant the same UIKit implementation would be, to find out if it's SwiftUI framework, or this is just an expensive UI, I guess, to build. Eric, do you have anything to add? And there are like a lot of small things, but
I mean, I've seen jump in the deep end and figure it out before you're 46. So I wrote the Swift UI code, you optimized it.
I think we're very comfortable with the performance, but it's not where we want it to be. So our goal is to improve it over time. And we haven't really let it into some of the more performance critical, or like where we pay more attention to performance, but it's giving us time to learn and iterate.
I think our approach right now is if you're doing something new, you need a justification not to do it in SwiftUI. And performance concerns can be one of those justifications, but I don't like SwiftUI is not.
Okay, Ed asked to unmute for his question, so I'm going to do that now.
Hi, thanks for the talk. So you had mentioned that you had an application that was rendering performant, or needed to be rendering performant for whatever reasons. And I understand that can apply to certain scenarios, lots of applications, but in general, if we're writing an app, there's a lot of, well, I'm just coding something despite best practices. You're just kind of coding along in SwiftUI, and you're looking at the interface and it looks fine. And the, perceived performance is adequate for general users. Have there been any guidelines you've kind of noted to say things to look out for that would indicate, okay, maybe you do have a problem that can be addressed in SwiftUI? Any flags?
Yes, absolutely. So I guess if you have baselines, or you're observing performance of your application, like we use Xcode metrics in addition to other metrics, but if that's something that you're paying attention to, you'll see this regression in your production application. And ideally, you find that before, but if you ship a feature, and Xcode metrics is informing you that you've regressed on your scroll hitch and hang metrics, and in that release, the difference is that you've added a new SwiftUI feature. That's a good clue to go and investigate that, to determine what's going on. But the way you would do that certainly is with instruments, or the way I would do it is with instruments. And some of these are defined for you already. So if you're using the SwiftUI instrument, it will tell you these are slow, what it considers slow view bodies, slow frames. And those would be worth investigating to determine, if you have some of those common issues in your code. And then separately, the hitch instrument, which I'm not, or the hitch template, is another great one. And we'll show you some of those same same problem. So it will not necessarily show you the how it relates to your SwiftUI code, but you can combine them. You can add the hitch instrument to your SwiftUI, but the recording mode is sort of asynchronous with that one. So I'd like to start with this one, or perhaps start with the hitch instrument, determine, okay, there is definitely a hitch, and then go to SwiftUI template to dig deeper into the SwiftUI code.
Okay.
Red
Thanks.
flag, are you asking about?
I was looking for some red flags, maybe without having to go dig in and deep into the whole debug process. But that's fine.
I mean, this is certainly something you wouldn't do unless you're like, I find it super interesting, and I think it's helped me understand how SwiftUI works better. So for me, it's valuable. I'd say if you're happy with your SwiftUI code and its performance, then you don't need to really be spending time here. But most of this would start when you're diagnosing a problem. And for us, the problem was when we compared it side by side to some of our UI code, the performance was poor.
Okay, thanks.
I guess going off of what you were just talking about is doing an instruments run or anything part of your release cycle for each version of the app?
Yes.
And how does that, can you tell us a little bit about that?
Yeah, I think Scott maybe mentioned that there's, or someone was talking about like automated performance testing. And we're not there yet. We don't have like automated performance testing as part of our CI tech suite, for example. But that's something my manager is really interested in introducing. So we're sort of evaluating how we would do that. But we do include, so one change that I've affected on my team is that for every feature, as part of the defined scope, like minimum set of requirements that we define, we're including accessibility, and that is scoped, by the team. And we always include performance, and that includes like evaluation and mostly confirmation that we're not regressing the existing metrics, and to determine if there are like bottlenecks that we can solve before we ship it, or at least to identify those, communicate them, like, okay, this is sort of a performance problem, and then making the decision as a team with what to do.
Hi, so I have one question. Can we do anything to optimize it for, say, low power mode or something like that? Because I have developed my app and it doesn't work as good in low power mode as compared to a normal, like, non-low power mode thing.
So you're talking about like iOS's low power mode. Back to the question about the refresh rates. So the refresh rate on a hardware that supports like dynamic refresh rate would be slowed down. And we're doing that to say battery. So I'd say there's not much you can do if you want. You can't really opt out of what the hardware is going to do. But certainly you can evaluate your application under those conditions, and maybe they would be more visible in that constrained environment. So, like on the flip side, if you're on a device that supports the faster refresh rate, like 120 hertz, and you have only 8.3 milliseconds to render your frame, scroll performance will most likely look a lot worse because you've mostly been paying attention to its performance in this condition where it's 16, twice the time. So again, I think profiling is the same. Everything that we just talked about would also apply in that condition, I think.
Hey, thank you. Any other questions? I think we could maybe take time for one more. Going once? Yeah, went twice? All right, well, thank you, Mac.
Thanks for having me and letting me practice my talk again.
Hey, let's just get quickly through the wrap-up announcements. All right, so as usual, if you're interested in speaking, I can send out the form. Because subscribe to our YouTube channel to catch this recap as well as our previous ones. We do have a Mastodon. I'm still not good about posting on it. For people here, I have stickers. And there's one late breaking announcement I didn't get time to put in here, but as you know, we are part of Dev Community, which is a combination of a bunch of different meetup groups. Our GDG group, some of our friends on the Android side, they're having their first DevFest DC event since 2019, I guess. Can't remember if we had it early 2020 or not, but they're having their first person event. It will be a kind of a mini DevFest DC event one day. Friday, October 20th. That is, you can find that through the GDG DC online event, and I'll also send out information for that through our meetup. But I know they're trying to look to kick that off with a big bang. It's going to be a small one, just to kind of get themselves back on their feet. But if anyone is interested in that, please let me know, and it would help, just our other co-organized groups as well. And then for next month, I am anticipating we will hopefully be here next month. I know we were kind of flip-flopping if November or December would be our month off, but we did actually get a new round of speakers. We also do have to wait for this talk to be officially be approved to be given, but most likely we are looking at our next talk to be about Doxy and Xcode 15, a guide to rich developer documentation. So hope to catch people then. With that, thank you everyone for coming.